My name is Mr. Carlson, and I'm a secondary mathematics teacher at Mission Heights Preparatory High School in Casa Grande, Arizona. I simply just teach statistics, algebra 2, trigonometry, pre-calculus, and as well as philosophy and AP Calc. And I'm excited for the possibility for our students to receive, and especially our school to receive, a 3D printer. So if I were to receive a 3D printer, I would definitely use it for my AP Calculus students. In this class, we discover a myriad of different things, but specifically how volumes of certain objects can be found using a calculus technique called integration. So integration is basically finding the area underneath a curve of a graph of the function. These volumes can be made into 3D objects, believe it or not, which provide the student an avenue in which to express his or her learning in a concrete manner. So one lesson I could honestly use a 3D printer for is an introduction to solids of volumes and revolutions. So a learning target could be provide a meaningful model of these volumes and an explanation to students about how area and volume are not just related, but how they can be modeled using approximate sum of parts. So these sum of parts could be thin cross sections of a solid or thin slices of an area with a thickness that we call dx, which is a calculus term for delta x, when it's approaching or approximately approaching 0. So ultimately, how integration can be used to find the volume of a solid. That's the learning target. So I would first review the lesson involving how to find an area underneath the curve. With solids, it would be a cross-section of the revolved solid. So I would then go into several methods of integration. And the 3 basic methods of integration with regarding solids is disk method, washer method, and shell method. So essentially, we would use a 3D printer, create these disks with whatever formula we decide, and add them or layer them successfully on top of each other. We would then compare our 2D math models with our 3D printer models. So we would make platforms for their solids, use 2 disk methods. We would then also use a washer method. We could also then use a 2 integral required method, which is basically bounding the area and the volume together. All we would need to obtain is 2 little rods or 3 little rods to help support this. So this is just a taste of what we could do for AP Calculus, but for our MHP teachers, we could use it for anything. For social studies, we could research and print artifacts and monuments of different civilizations. In English, we could use it for Shakespeare lessons, so for Hamlet, Ophelia's Flowers. In science, we could use it for physics to make a bridge or design a bridge, or Newton's laws of motion, and help calculate those quantities. Such a printer would help enrich the success of our students through visual aids, the state-of-the-art learning and activities, and provide memorable experiences. At MHP, we, as our motto, help prepare every student to succeed, and we know a 3D printer will help create such an environment.